Hello, Hornets. In this video, we're going to be talking about the last operation that we use. We've seen the product rule, the quotient rule, sums and differences, but what we haven't yet seen is the chain rule with implicit differentiation. So that's what we're going to look at next. So I've got a problem here. We're going to be taking a look at the sine of y squared. Notice it doesn't have to be all that complicated for us to have a difficult process. So we're going to take our d dx. We're going to work with the sine first in our chain rule. This is going to give us cosine, and we leave the y squared alone, times the derivative d dx, and now we're at that y squared, right? So we're going to have cosine of y squared times 2y dy dx. And I'm just going to clean this up so that I have my 2y cosine y squared, and then I'm going to have my dy dx at the end. Let's take a look at another one. Nice and complex. Now we can do almost anything. So let's do d dx, and we're going to work with the tangent of x, y. Once again, trying to keep it very simple. We don't want to take it up too big. The larger they get, the worse they get. So we're going to start with the inside here, secant squared x times y, and then we're going to have our derivative dx of x, y. Now this is where we have our product rule. So we have secant squared xy times y plus x dy dx. Now I'm going to distribute this. So I'm going to have a y secant squared xy plus x secant squared xy dy dx. Okay. So let's look at them. Go back one more time over them. Then we'll do another one. We're looking at our f function, then our g of x. Chain rule is f prime g of x times g prime of x. Got too many parentheses there, but hopefully you get the point. So if I'm looking at that as cosine y squared, the cosine came from the sine. That was our first derivative piece. Then we work with the derivative of the inside, and then we have our dy dx, which was the derivative of y. Move the 2y to the front. Next one. Take the derivative of the outside, leave the inside alone, then take the derivative of the inside. Notice this is now our product rule, and I then distribute the piece, and it's that distribution that tends to make it more disgusting, a little bit uglier. Let's do one more. So for our next one, let's look at something a little bit more complex, the cosine of x squared y. Now that x squared y, we know we're going to have the product rule, so we will have to distribute. So look ahead at what you're doing. Think about how this is going to work. Taking my derivative, d dx. Cosine goes to negative sine. We leave the inside alone. This is what we will distribute into the product rule, x squared y. So we have negative sine x squared y times 2xy plus x squared dy dx. We're going to now distribute negative 2xy sine of x squared y minus x squared sine x squared y dy dx. And there it is. all its glory. Now you'll notice we haven't even started working on solving for y prime yet. Half of our job is to make sure that we know how to differentiate implicitly with whatever it is we're given. If we can do that and we know our processes and what we're trying to do, the rest is a piece of cake. Alrighty. The next video we'll be taking a look at how we work with an equation with implicit differentiation. And we'll see how that influences what we do. Thank you, Hornets.